Hello, good people. Let's take a look at question 11 from Mathematics Paper 1, November 2025. We are given that a survey was conducted among female and male learners at a school about which type of cold drink they preferred. Some preferred juice, some preferred energy drinks, right? And here is the data presented to us in the form of a table, right? So they say that on 11.1.1, the events being made and preferring juice are independent. Show that E is 84. If being made and preferring juice are independent, first things first, write down the formula for independent events. So we know that the probability of male, right, multiplied by the probability of preferring juice, I'm just going to call it J, is equals to the probability of male and J, right? Male and juice, being a male and getting juice, right? So um, how would we find the probability of being male? We're just going to take the total number of males in the survey divided by the total number of people. So F, right, it's an unknown variable there, but we can get it because F is going to be this 36 plus 54, right? So let's put that in our calculator and see how much we get. 36 plus 54, that gives us 90, right? So there are 90 males in the survey. So 90. So the probability of being male is basically 90 over 120 multiplied by the probability of getting juice. So the total of getting juice is E, right? Which is what we are calculating there, right? The probability of getting juice irregardless or regardless of being male or female, right? So it's going to be E over 220, right? Where is where is this 120 coming from? Sorry, this is 210. I flipped the numbers. 210, here 210 as well, is equals to the probability of male and getting juice, right? Male and preferring juice. So this one, we're gonna get it on the table. How we're gonna get it? We're gonna draw a line on the male going like that, and a line from juice going down like that, where the two lines meet. So this is the number of males who prefer juice. So how many are they? There are 36 there, right? So that number there is 36. So it's gonna be 36 over the number in sample space 210. Then we can solve for the value of E. All right, so here 136 can simply cancel the, sorry, this one of the 210s can cancel this 210. Then we are left with 90 over 210 multiplied by E is equals to 36. Then I can write this as E equals to 36 multiplied by 210 divided by 90. Let's put that in our calculators. 36 multiplied by 210 over 90, 84, right? So it's correct. So E is 84. So we were able to prove that here it's 84, right? So if here it's 84, we can then find the value of D. It's going to be simple, right? It's going to be 210 minus 84. 210 minus 84, that's 126. So we know that here it's 126. Then we can also find the value of B. It's going to be 126 minus 54. 126 minus 54, that's 72. The value here is 72. We can find the value of C, 210 minus 90. 210 minus 90, that's 120. So the value here would be 120. We can also find the value of A, 84 minus 36. 84 minus 36, that's 48. So the value here is 48 minus 1 problem. So now let's move on to the next question, 11.2. 11.1.2. calculate the probability that a female learner, so we are given that this learner is a female, chosen at random from the group, will like energy drink. So we need to say out of the female learners, how many like energy drink. So there are 48 females, sorry, not 48, that like energy drink. There are actually 72 females that like energy drink out of the total number of females, right? So therefore the probability would be equals to 72 over 120, right? Let's put that in our calculators. 72 divided by 120, that's 0.6 or 3 over 5. 3 over 5, right? And that's how you would calculate it. Yeah? It's 3 marks because of you had to calculate these values first. Yeah? Now let's move on to 11.2, right? They say that at a kiosk, 120 people buy either a cup of coffee or a bottle of water. The chance of rain on a given day is 75%. All right. So on a day, it can either rain or not rain, right? So this would be rain, R for rain, R prime would be for no rain. Let me just indicate here, R prime is no rain. Yeah? Then on a day that is raining, you can either buy coffee or you can buy water, right? So you can either buy coffee or water. And even on a day that is not raining, you have two options: buy coffee or water, right? We are further given that the chance of rain is 75% on any given day. So this would be 75% here, 0.75, this would be 0.25, right? So the chance of raining is 75%. They say that the chance of a person buying a cup of coffee on a rainy day is 3 times the chance of a person buying coffee on a non-rainy day. So where is the rainy day? Coffee on a rainy day is this one, right? So they say that it's 3 times this one. So we can call this one 3p and this one would be p, right? So the probability here is 3 times the probability here, as you can see, right? So they say that the probability of a person buying coffee on any given day is 7 over 12, right? So you know that, okay, we would do this, right? We would show all our possibilities, all our different combinations. We would have this possibility. It can rain and you might buy coffee, or it can rain, you buy water, or it can rain, not rain, sorry, then you buy coffee, then it can also not rain, then you buy water, right? So the probability of buying coffee, the overall probability of buying coffee, this one plus that one should give us 7 over 12, right? So now, how would we get that one? We know that this one, RC, would be basically multiplying this and that, right? So it would be 0.75 multiplied by 3p, which would give us, we'll find it in RW, would be 0.75 multiplied by, all right. Oh, wait, we're not buying water. Sorry, we're not buying water, we're buying coffee, right? We're buying coffee. They say that the probability, I made a mistake there, the probability of a person buying coffee on any given day. So we are interested in this two, right? On this two, right? That's what we are interested on. So this one would be 0.25 multiplied by p, right? So we're gonna take this two, add them, they should equate to 7 over 12, right? So we can therefore say 0.75 multiplied by 3p plus 0.25 multiplied by p is equals to 7 over 12, right? Then let's solve for P here. We're gonna have P as, all right, okay, let's simplify these things first. 0.75 multiplied by 3, that's 2.25p, 2.25p plus 0.25p. So 2.25 plus 0.25, 2.25 plus 0.25, that actually gives us 2.5. So on this side we have 2.5p, 2.5p is equals to 7 over 12. So basically P is 7 over 12 divided by 2.5. 7 divided by 12 divided by 2.5. That gives us 7 over 30. So therefore P equals to 7 over 30, right? Remember P is what? P is the probability here, right? It's the probability here. So now they say that here it's 7 over 30. They say we should calculate the number of coffee, or the number of cups of coffee that will be sold on a non-rainy day, right? So we're looking for the number of coffee cups that will be sold on a non-rainy day. So therefore, remember, probability is equals to number in event over the number in sample space, right? So the probability is 7 over 30. The number in event is what we are looking for, over the number in sample space. In this case is they give us the total number of people as 120, right? Over 120. So therefore, number of people who will buy coffee on a day that is not raining would be 120 multiplied by 7 over 30. 120 multiplied by 7 over 30, which is 28, right? So it's 28 people. I hope it makes sense now. Then you get your 4 marks. Now let's move on to the next question. The question on, what's this, counting principle, 11.3. They say that 8 runners compete in a race where there are no tied finishes, right? It's either you are number 1 or number 2. There's no, we are both number 1. So Bongi and Andrew are 2 of the competitors, right? So let's just name the runners. Runner 1, let's say runner 2, runner 3, runner 4, runner 5, runner 6, runner 7. Okay, wait, we can call this one Bongi, B for Bongi, then A for Andrew, right? A for Andrew, like that. So they say that on the first question, 11.3.1, calculate the total number of possible ways in which the 8 runners can finish the race if Bongi finishes in a position immediately after Andrew, right? So they would be always together, right? So they would always be together, but then with them being together always, Bongi needs to be after, right? So we can take this thing as a single entity, right? We can take BA as a single entity, but then now A needs to come before B always. So A needs to come before B, right? Andrew needs to come before B, right? So we can arrange these 7 entities on 7 spaces, right? 1, 2, 3, 4, 5, 6, 7, right? So it would be 7, 6, 5, 4, 3, 2, 1. Then we multiply the options, right? So remember that 7 here, it's the number of options that could go here. So on this first position, we have 7 options, right? On this one, we have 6 options. On this one, we have 5, 4, 3, 2, 1, right? So normally after doing this, we would multiply this by 2 factorial, further arranging them inside this box, right? meaning that Bongi can either become before Andrew, or Andrew can come before. But then in this case, we are not supposed to do that because they've restricted us and said that Bongi would always be after. So no need for us to multiply by 2, right? So we're just going to go with this 7 factorial as our answer. So this is 7 factorial. Let's put that in our calculator. 7 shift factorial. This factorial here. This calculator in a factorial. I guess I'm just gonna leave it. I'm just gonna leave the answer at 7 factorial there. Or let me use my manual calculator. 7 shift factorial. That's 50, 40. 50, 40 ways, right? Then 11.3.2, they say that we should calculate the probability that 2 or more runners finish the race after Andrew, but those 2 runners or more, they should be before Bongi. So in a line like this, where we have 1, 2, 3, 4, 5, 6, 7, 8 spaces, right? Remember, Andrew is always before Bongi. Let's say Andrew is here, right? There should be 2 or more runners between them, right? So if the 2 runners, let's say it's 2, let's go with 2, right? The 2 runners should be after Andrew, right? So Andrew is here. We would have 2 runners after Andrew. Let's say runner unknown, after Andrew. But then the 2 runners should be before Bongi. So Bongi needs to be here. So in essence, what they're saying is that the runners, the 2 or more runners should be between Andrew and Bongi. That's what the question is saying. So we can then see how many different combinations we can make, because it's not always the case that A would always be here. Because look, let's just keep it at 2 people being between them. Yeah? You'd see 1, 2, 3, 4, 5, 6, 7, 8 still. Let me take it higher. So 1, 2, 3, 4, 5, 6, 7, 8. So look, if Andrew is here, we need 2 runners between them. Then Bongi would be here, right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. If Andrew is on the 3rd position, 2 runners between them, then Bongi would be here. If 1, 2, 3, 4, 5, 6, 7, 8. If now Andrew is on the 4th position, we need 2 runners between them. Then Bongi can be here, right? Let's take things up a little bit just to make space. So I'm just gonna wipe this one out just to create space. Yeah? Let me take this one up. Yeah. So we can have another one where we have 1, 2, 3, 4, 5, 6, 7, 8, where now Andrew is on, Bongi is here, Andrew is here. Then we have 2 runners between, right? So remember, these are not all the options. We have other options where we have 3 runners between them. We have other options where we have 4 runners between them, 5 and 6 runners between them, right? So let's calculate first the number of ways where now it's at 2 people between them, right? So this would be how many factorial? How many Andrews are there? There's 1 Andrew. How many Bongis are there? There's 1 Bongi. Then there's the remaining 6. We can arrange them in 6, 5, 4, 3, 2, 1 ways. So this, if I multiply everything here, it would be 6 factorial, right? That would be 6 factorial. So basically everything here would be 6 factorial. So how many 6 factorials? Basically, this is for option 1, right? When there are two learners or two runners between, right? So this would be 1, 2, 3, 4, 5, 5 times 6 factorial. This is not odd, right? Because this is a case whereby there are only two runners between them. So for example, if I can choose to move um, um, Bongi here and place him here, then place another runner here, right? So now here there are 3 people, right? So let's remove here. Let's remove this just to show you exactly what's happening, right? Because it's also a possibility that we have 3 people between them, right? So 3. Okay, but then this one won't be a possibility, right? So look, this would be these ones, excluding this one, because if I put Bongi here, then it's 2 people in between, and I've already included this kind of line in this one, right? So we don't need this one. We're now adding the number of ways we can arrange them when we have 3 people in between, right? So now it would be 1, 2, 3, 4. 4 times how many factorial? 4. So option 2 would be 4 multiplied by 6 factorial. I hope that makes sense, né, guys? So we can do that again. Put now, instead of 3, put 4 people between them and see how many options we would have, right? So let's take this one out. We don't need it. It's most likely going to be 3 times 6 factorial as well. Now look, we have 4 people in between, right? Now we have 4 people in between, and Bongi is here. Another person in between, Bongi is here. Another person in between, Bongi is here, right? So now this one is no longer an option now, because if we put Bongi here now, it's 3 people in between, so we don't include this one. So let's cancel it out. Let's cancel it out. So our option 3 is gonna be equals to 1, 2, 3, 3 times 6 factorial, right? So now let's put 5 people in between. Remember, here we had 2 people, here we had 3, here we had 4 in between. Now let's put 5 people in between them. So there would be a 5th person here, unknown, 5th person unknown there. Wait, okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. The 5th would have to be here. And now this one won't make sense. So we're going to have to take this one out, this line out. So this would actually be option number 4. We would have 2 times 6 factorial, right? Then the last option, that's when we have now 6 people in between, right? When we have 6 people in between, this would be 1, 2, 3, 4, 5, another person here, and then Bongi being here. Now we have 6 people in between, right? So this one would go out because it would be under 5 people in between. So we would have to take this one out. So the last one would be option 5, where we have 6 factorial, right? Where we have just 6 factorial. So this would be our number in which we can arrange them if these conditions are met, right? So this is 5 plus 3 plus 2, which is another 5, that's 10, plus 4 plus 1, that's 15 times 6 factorial. So this is number in event. It's going to be 15 times 6 factorial. Our number in sample space would be the number of ways we would arrange 8 people without any restrictions, right? So this would be 8 factorial, right? So this would be, our answer would be 15 times 6 factorial. I don't know where's the factorial here, but let me just put it in on my manual calculator. 15 times 6 shift factorial over 8 shift factorial. That's 15 over 56. And this is how I calculated the probability, guys. I hope it makes sense though. And thank you guys for watching the video.